This is Miss Park, and this video is about the Pythagorean Theorem. So Pythagorean Theorem was discovered by Pythagoras, which here is actually spelled wrong, so here's how you actually spell it. Pythagoras, okay, who was a Greek mathematician. Now, actually, it's not true. The Pythagorean Theorem was actually used 1,000 years before Pythagoras in India. But it's known with his name, so even though he wasn't the one who actually discovered it. It applies only to right-angled triangles. And it can be expressed geometrically or algebraically, so I'm going to show you. So geometrically, what it means is that if you have this right-angled triangle with side lengths A, B, and C, okay, if you construct a square with side length A by A, and then another square with side length B by B, so this is B and this is A, then the areas of those two squares will add up to this other square, the area of this other square that is C by C. So squares placed along the sides of a right-angled triangle have side lengths A, B, and C, and areas big A, big B, and big C. If big C is the area of the largest square, then A plus B equals C. And now these things are referring to the capital letters, which are the areas. So the area of B, area of A plus the area of B equals the area of C. Now algebraically, how it looks is we're not drawing the squares. Algebraically, we say, well, the area of a side length that has little a little a by little a is going to be little a squared. And then the other one is little b by little b, so that area is little b squared, and so that will add up to little c squared. So geometrically is with the squares, algebraically is with the side length. So let's use this to find the missing side length. For the shorter sides, you can call them A and B, B and A, or any other letters that you want. It doesn't matter which is which. So let's write a squared plus b squared equals c squared. And I'll fill in the numbers. 3 squared plus 4 squared equals c squared. And this is 9 plus 16 equals c squared. 25 equals c squared. And take the square root of both sides. And you get c is equal to 5. That means this hypotenuse is equal to 5. Okay, so that's how we find the missing side of a right-angled triangle when you know the other two sides. Let's do another one. Look here, we're missing the shorter side. So it's already called A, so I'll call this one B. So A squared plus B squared equals C squared. Now little a we don't know, but B is a 6, so 6 squared equals 10 squared. So we have A squared plus 36 equals 100. All right, now we want to solve for A. We've got to isolate it, so we'll subtract 36 from both sides. That will leave us with just a squared here, and the 100 minus the 36 there. A squared is equal to 64, and so a is the square root of 64, and so a is 8. And that's how you solve for the shorter side. Okay, and so here's some practice on this page. This is in our booklet, so you can do that practice. Let's do this one. A ladder leans against the wall that is 4 meters high. If the foot of the ladder is 2 meters away from the bottom of the wall, so this is 2 meters, how long is the ladder? So you can call this X. Let's call it X, just so that we're not fixed on A, B, and C. But if that's X, and that's the longest side, then these two are the shorter sides. So A squared plus B squared equals C squared. Little a is 4, little b is 2, and that's C squared. So 16 plus 4 equals c squared. So 20 equals c squared. So c is the square root of 20. And it says to round to 1 decimal place. So square root of 20 in the calculator gives us approximately 4.5. And I'm going to put this little dot here because I'm rounding. So approximately 4.5 meters. Okay, now this is a word problem. So we always answer with a concluding statement. Therefore, the ladder is approximately 4.5 meters long. All right. And then here's another one. A standard Canadian football field without the end zones is approximately 101 meters by 59 meters. So here's 101 by 59. And then it says, how much shorter is it to walk diagonally across the field than across the sidelines? So here's the diagonal. So it's saying if I walked along the sidelines, I'd be going 101. Let's say I wanted to get from this point here to this point here, from A to B. Then I would have to go 59 meters and then another 101 meters. Or I could go through the diagonal. So again, we'll use a squared plus b squared equals c squared. So the two shorter sides are 59 squared plus 101 squared equals c squared. Add those up. So I'm going to actually do it all at once in my calculator. Doesn't matter. And I get 13682. So c squared is 13682. So c is the square root of that, which is about 117 meters. Okay, now if I walked along the edges, I would be walking 59 meters plus 101 meters, which is 160 meters. So you can see it's a good shortcut to go through the diagonal. So how much shorter is it? Well, let's go 160 minus 117 is 43. Therefore, it is 43 meters shorter to walk diagonally. Okay, so you have practice in the textbook and in our course pack, so please practice, and thanks for watching.